Here problem number 1. The diagram shows the combination of the logic gates. Input P is at a logic state 0, that is nothing but for low, and input Q is at logic state 1, that is nothing but high. What are the logic states at output X and output Y? So this combination of the logic gates is given over here, and in digital electronics we have learned several kinds of logic gates. Out of them, 3 logic gates are used over here. You can see this one is nothing but the NOT gate, this is the NAND gate, and this is nothing but NOR gate. And for reference, I have attached here the truth tables of the NOT gate, NAND gate, and the NOR gate. You can study, and you have to see all the gates once again in the lecture video to solve the MCQs and the structure problems of the logic gates. Here these are the two inputs, P and Q are the inputs, X and Y are nothing but the outputs. So at input P it is nothing but 0. We have in the inputs in the logic gates we have either 0 or 1. So here 0 is input for the P, 1 is the input for the Q. So inputs are given, and we need to find out what is the output X and Y. So here see this is nothing but the NOT gate, and you can see here this input for the NOT gate is 0. So what should be the output? So you can see this truth table. For 0 we are getting 1 as the output. So the output of the NOT gate here, it will be 1. So I will write here for reference, it is nothing but the 1. Okay, and that output is going to be the input here for this NAND gate. For NAND gate we get actually 2 inputs. For NOT it is only 1, but for NAND we need 2 inputs. So here one of the input is nothing but 1, which is nothing but the output from this NOT gate. And what is the another input here? Another input is coming out from this this Q input. So Q input is what? It is nothing but 1. So this will be the input. Here you can see this is the common junction. This one is the common junction, and here it is the input for NAND gate. So NAND gate another input is nothing but 1. Okay, it is coming from this input Q. Again you can see this is the common junction, so it is again the input for this another gate, which is nothing but the NOR gate. So here also the input is, one of the input is 1. Another input is coming from the output of this NAND gate. Here this is a NAND gate, and 2 inputs are nothing but 1 and 1. So here you can see this is the truth table of the NAND gate. If the 2 inputs are 1 and 1, you can see the last here row. If the 2 inputs are 1 and 1, the output is nothing but 0. So here the output I will write over here, it is nothing but 0. Now this 0 is nothing but the output X, because this is a common junction, it is nothing but the output X, and also it is here, it will be coming like this, and it is a input for this NOR gate as well. Okay, it is nothing but 0. Okay, so we get now 2 inputs for this NOR gate. One is coming from the output of the NAND gate, and one is coming directly from the Q. So what are the inputs for NOT gate now? It is 0 and 1. And now here you can see the truth table of the NOT gate. The inputs 0 and 1. You can see this input is 0 and 1. And for that output is nothing but 0. So here I will write the output of the NOR gate. It is nothing but 0. Okay, so I hope you understood this combination here. The junction meaning it is going to be same for both the paths. Here also it is going to be same for both the paths. And here what outputs we are getting? At output X it is 0, at output Y also it is 0, and in the options you can see the output X and Y, it is 0 for option number 1. So option number 1 is the correct answer. Now we will see the problem number 2. Which symbol represents the AND gate? So which one is the AND gate over here? What is this gate? It is nothing but the NOR gate. We have just seen it is nothing but the NOR gate. This one, you can see this one, it is nothing but the NOR gate. What is this? This is nothing but the OR gate. Okay, this is OR gate. This is NAND gate. We had also seen over here. This is nothing but the NAND gate. So if you remove this circle, okay, this dot from the NOR gate, it becomes actually the OR gate. This is the NAND gate. And what is this? If you remove this, again this small circle from the NAND gate, this becomes the AND gate. So this is our symbol for the AND gate. Okay, we are finishing our MCQs for digital electronics here. Now we will see the structured problems. Now we will see the structured problems for the digital electronics. Here you can read the question number 1. Figure 10.1 shows the symbol for the circuit component and you have to name the component. So which component is this? So here you can see this all components we had seen in the electric circuit chapter, and this I am going to attach here for the reference. So you can see over here in that case, this is our answer. This one is our answer, which is nothing but the light emitting diode. So we have to write over here. You can write down either LED directly or light emitting diode, both the ways. So I will write here light emitting diode, or also you can put it over directly LED. Okay, so here question number B. In the space below, draw the symbol for the NOT gate. Okay. In the MCQ, we had seen the symbol for the NOT gate. All the symbols of the gate we have to revise before we are going to solve any problem in the digital electronics. So what was the NOT gate basically? We had seen it is nothing but the only the kind of triangle we are getting in that case. So here I am going to draw the triangle. Can draw like this. And there is a one small circle. We are getting small dot over here. Okay, here in case of the NOT gate, only one input you will get over here. This is the input, and this one is nothing but the output. Okay, so this is the symbol for the NOT gate. This is the symbol for this NOT gate. Okay, now we will move towards the part B of the problem. Here in figure 10.2, which shows the digital circuit, okay, and you have to complete the truth table for this circuit. Okay. So this is the circuit given, and you can see two kinds of gate are attached in this circuit. So this gate is nothing but the AND gate, and this gate is nothing but the OR gate. Okay, if you put dots over here, then it becomes the NAND gate. If you put the dot over here, it becomes the NOR gate that we had seen in the MCQ. So we are removing that dots, then it becomes the AND gate and it becomes the OR gate. Okay, and we have to complete this truth table which is given over here. So here we are for the AND gate we need the two inputs. So this inputs A and B, these inputs are the inputs for the AND gate, and for OR gate also we need the two inputs. Here D is the input for the OR gate, and C, which is the output of the AND gate, becomes the input, another input for the OR gate. Okay, and from C and D, okay, C and D, these are the inputs of the OR gate. From that C and D, we get the E as the output from this OR gate, or which is our final output of the entire circuit. So the truth table for the AND gate is given over here for reference, and the truth table for OR gate is also given here for the reference. So it is a very simple circuit. If you go step by step, then you can feel it is a very easy. Here, first of all, we will find out this. We will first of all find out this output C. Okay, and then we will consider C and D as the inputs, and then at last we will find out this output E. So our goal is to find out just the output C as of now, which is the output of this AND gate, and the inputs are what? A and B. And here you can see in the truth table different kind of combinations of the input are already given, so no need to take any worry about that. So here the output C is the output of this AND gate, and the truth table we can find out that output with the help of this truth table. You can see first input is what, 0 and 0. For 0 and 0 the output, you can see here, for 0 and 0 output is nothing but the 0. So you can put here it is the output 0. Then the second is the same case, 0 and 0 inputs. So again the 0 and 0 input, the output is 0. So I have to put the again the same 0. Then third case, inputs are 0 and 1. You can see this third row, input 0 and 1, the output you are getting as a 0. Again I have to put here 0. Then the fourth case is the same thing, 0 1. So again the output will become the 0. So the fifth case, you can see the inputs are 1 and 0, and in this truth table you can see the second column, inputs are 1 0 and output is coming out to be 0. So here again I will write 0. Next case is again the same thing, inputs are 1 and 0, so output is the same thing, that is nothing but 0. You can see this one, second last case, the inputs are 1 and 1. So in the truth table you can see the last row, 1 and 1, the output is coming out to be 1. So here the output will be 1. And the last case, the same inputs are there, 1 and 1, so output will become the 1. So this the outputs we found, the output of the C, which is nothing but the output of this AND gate from the inputs A and B given from these columns and using this truth table. Now you can see C and D. Now we obtain the C and D. D is already given, C we just obtained. So C and D are the inputs of this OR gate. Okay, so C we found, D is already given. Now we will find out now the output E of the OR gate. Okay, so with the help of the truth table for the OR gate now. Okay, so here the inputs, these inputs we will see, use this C and D, these inputs we are going to use here to find out the output E. So here the first inputs are 0 and 0. Okay, you can use this truth table, you can see 0 and 0, the output is nothing but 0. So I will put here 0. The next inputs are 0 and 1. So you can see here the third row, 0 and 1, the output is nothing but 1. So here I will put here the output as a 1. Next case, the inputs are 0 and 0. So we have already seen it is nothing but 0. So here I will put 0. The next inputs are 0 and 1. For 0 and 1 we have already seen this output is nothing but 1. You can also see in the truth table, for 0 and 1 it is coming out to be 1. For 0 and 0 again the same case, so output is nothing but the same, it is nothing but the 0. So here it will be 0. Then for 0 and 1 again the same case, output is nothing but 1. Those are repeating the things, repeating the values. Here the next input is nothing but 1 and 0. So you can see in the truth table it is input, second row you can see 1 and 0, the output is 1. So again I will put over here the output as a 1. The last case we can see over here the inputs are 1 and 1. Okay, so inputs on 1 and 1, you can see that last row in the column in this truth table, you can see 1 and 1, the output is coming out to be 1. Okay, so we found the output E of the OR gate. Okay, so this is nothing but our answer, C and C and E. E is our final output of the overall combination. C is nothing but the output of this AND gate. So this way we can solve this the truth table for the entire circuit using the truth tables of AND and OR gate. Provided whatever kind of logic gates are given, here it is given as AND and OR gate. It can be anything. You have to know the truth tables of all those logic gates, and using those truth table you can find out any kind of such circuit outputs. Now we will see the next part, the part C of the question. So the part C suggests the modification to the circuit in the figure 10.2 to produce the output Z in the truth table below. It may help you to compare this truth table with the truth table what we found in the part B of the question. So here, what is our goal over here? We want the output as the this output Z. This should be the output now. So instead of E, this was our final output. In the previous part, we had seen this was our circuit diagram, and the final output was E. Now instead of E, we want the final output as the Z. Okay. So how we can obtain Z as a final output? Here you can see all these. In this column you can see all the entries are 0 except the last one, which is nothing but the 1. Okay, how can we obtain this E? If you consider this E as the Z, then how can you convert that E into the Z output? Okay, what kind of modification you need in this circuit diagram? Okay, so let's see what we had obtained in the part B. That circuit, that truth table we will see, and we will see what kind of modification we can do. So basically we need the modification in the circuit so that we will get the output as a Z instead of E. So what was output Z? We had all these entries were 0 except this one, which is nothing but the 1 as it is. Okay, so how can we get all these entries to be 0? So we have to replace it. If you observe, this is our input C, which remains the same, and which is nothing but input D, which remains the same. So how come we get all the zeros over here and 1 over here? So we can see from these inputs, if you see this truth tables of the AND and OR gate, you can see if I replace this OR gate with the AND gate, okay, what will happen? All these entries will be coming out to be 0 and the last one will be 1, because you can see these all combinations of the input from C to D, one of them is a 0. Okay, so you can see from this to this, all the combination, one of the input is nothing but 0, and on the last entry all the inputs are 1. So we can say in the AND gate we will get 0 if one of the entry is 0, and we will get 1 only if both the entries are 1. So we can get 0 here because one of the entry is 0, and we will get 1 here in the last entry because both the entries are 1. So if you replace this OR gate with the AND gate, we can have this Z as the output. So we will write that in part C. So we can write down here our answer. We will write down by replacing OR gate with AND gate. By replacing OR gate with the AND gate. Because if you replace the OR gate with the AND gate, this OR gate with the AND gate, then we will get the output Z instead of output E. Now we will see the next problem. So here is the problem number 2. You can see in figure 11.1, which shows the symbol for the logic gate and its truth table. Here this is the logic gate and this is the truth table. We have to name this logic gate. So we are already seeing this is nothing but the AND gate in the previous problem as well. In the AND gate we get all the output as a 0 if one of the inputs is 0. You can see this one of the input here, it is 0 in A and B, and we will get the output 1 only if all the inputs are 1. So this gate is nothing but the AND gate. So here I will write down it is nothing but the AND gate. Now we will see the sub question number 2 in this part A. Complete the truth table for the logic gate given in this figure 11.2. So you can see this figure is given. What is this figure? We had already seen this kind of logic gate also. This is nothing but the NOR gate. What is a NOR gate? NOR gate is basically, it is the OR gate. You can say it is nothing but the OR gate plus NOT gate. So we can say the addition of both of them is nothing but the NOR gate. To solve any truth table, I already told